Yes, I'm me too, Ganesh. Like, I want can you hear me?
Yeah, I can hear you.
I like to file for my answer, in my point of view, same thing, AWR report, ADDM report. So where we use that report and AWR report and explain plan, so how to match the current explain plan with previous explain plan, the performance based on in the time of performance, and in between some SQL tuning, not much, but to understand where to find the basic things to find out in the SQL tuning. So these are the requirements from my side.
So you are able to see my screen, right? Both of you?
Yes, yes.
So Sangha, I have captured whatever you have mentioned as well, right? Oracle architecture, SGA, PGA, Oracle memory architecture, right? SGA, PGA, and memory architecture. Okay. And what else?
Optimizer.
Okay, Oracle optimizer mode. What about Oracle statistics? Right.
Yes.
And we have
Yeah.
something called PL SQL profiler, right? Tuning
Yes, I heard.
PL SQL code. Okay. What else I'm missing out here? We will add to this as we proceed, right? So let me
Sure.
put it in the desktop, and I'll say Oracle Puff tuning class requirements. I will share this at the end of the class as well, right? I will put it in the paste, or I don't have you people's email ID. I will share it with
Yeah.
the institute, and in turn they will share what we'll be covering in this class. So as far as this,
And
yeah.
so, and we have the video recording as well, right? In video and the audio.
For this session, yes. Yeah, I just started the recording, so we'll have this recording as well. So
So normally I'm asking for future classes as well, right? You'll send the videos, right, of the classes.
for all the classes, I have to check with, yeah, I'll be sending it. The
Yeah.
GangBoard, I got
Which is
this
this?
go-to-meeting credentials from the institute, so I will confirm that. To
Sure,
confirm,
sure. Yes, sir.
to confirm regular class audio and video. Let me capture that as well, so that right, we don't miss out on.
Sure. Ideal. Yeah.
So I'm going to continue for another 40 minutes. Hope it's fine with you people, right? Both of you. 8:30 we started, so
Yes.
another 40 minutes I will continue. So as far as the performance tuning, sorry? Okay, okay. So indexes also will cover. So indexes is another topic that I can think of. So with respect to performance tuning, right? Anything you want to tune, or you want to get into the next stage in the technology that we are working on, right? Uh, the first step is to better understand how things work. So for a car mechanic, right, to tune the car, I think that's the best analogy I always use with the students, is he should understand the inner intricacies of the working of the car, so that, right, he can fine tune the car for higher performance. So it's the same everywhere, right? So if you want to write, I assume that, right, with you people, with the interest shown for this particular course, Oracle Performance Tuning, you would like to, the main focus of this course is to better understand, right, how Oracle internally works, and
Mhm.
what are the different tools basically Oracle provide, right, for us to fine tune it better. So these are the two things, and I can assure you, right, at the end of the course you will develop more interest towards performance tuning, and you will start reading more materials that's available in the Google, right? So I can assure you that the interest towards this subject will increase as we progress in the class. Okay.
Yes.
So with respect to the internal working of the SQL, right, it's basically first, right, performance tuning is more of, right, fine tuning a given SQL it can be at the SQL level. Performance tuning can happen at multiple levels, right? As you guys know, let's say a particular web application, the user has clicked on a button, a search query, is trying to do a search in the application. That particular individual activity is taking a lot of time. All other parts of the application is running fine, but only one specific part of my application. So here it boils down to a specific SQL. One of the SQL codes which has been running for so long, perfectly fine, suddenly you're seeing performance degradation. So that's one typical scenario we can say. You may be asked to fine tune. Suddenly the application.
Yep.
The second scenario is, right, all the users are saying the daily routine, I go and click download some 2 or 3 reports every day. I do this, and now all the users are complaining that at the system level it's running very slow. We don't know, we are seeing suddenly degradation. I'm trying to log in, it's taking me 10 minutes to log in. Usually in a second we'll log in, but 2 minutes, it's now taking me 2 minutes to load a page, and everyone is complaining. So the second scenario, what I'm saying is, right, the whole of application is suddenly down, right? And so that's typical scenario you will encounter. And the third scenario is, right, more likely you have a batch window and you're suddenly seeing the batch window, right, the jobs that are supposed to get completed is not getting completed. And this is happening suddenly. Till yesterday it ran fine, and today you are suddenly seeing a drop in the performance. It's taking more time. Or the same scenario, over a period of time you are seeing the performance degradation. Last month you used to complete in 2 hours, so it's 2.53, now it's taking 4 hours. So in a span of 1 month, the performance degradation has doubled. Right, the time taken for the batch job has increased from 2 hours to 4 hours. Right, so these are the different scenarios, right, where people will say, can you look into the code? So these are more like, right, SOS kind of situations where you have been asked to look into and provide a solution immediately. Right? So you're forced to say, look into this kind of situations and provide some alternatives, or tell why suddenly it's kind of degrading, the performance is degrading. I talked about the batch job, right? So most of the time in the batch jobs, right, it will be PL SQL code only, right? So, or it can be even, say you're doing a data transfer from one system to another system using materialized views. It's kind of getting slowed down. It's possible, but mostly with the batch jobs, it's the PL SQL code. And then the interesting part is, right, on the PL SQL code is we really don't know where the issue is, because my PL SQL program, the package calls another package, that package calls another procedure. For us to find out, right, exactly where the problem lies. That's the challenge. We really don't know where the problem is, and we have been asked to look into it, right? So these are all more of SOS kind of situations. But let's say that, right, a new module or a new application or a new piece of code is going to get into production, right? So that's the other way. The other side of the thing is being proactive. When I develop the SQL code, what are the things that I can do, right? It's more like, right, fine tuning, making sure that you build the things in the right way. That way the performance, the scalability is assured, right? Proactively at the time of development or at the time of testing, we want to recommend some performance testing, right? So that when the code is deployed in production, the code runs fine. Most of the environment, right, we will used to have performance testing environment itself, or in the release environment we do performance testing. So how, in your case, how was it like, Anil? You people do any performance testing before moving the code to production, or people just move the code to production?
No, we will do the in testing environment first. We will perform the, like, from application side, they will test all the code, everything before the going to production.
Okay, that's good. And yeah, so Sangamitra, I assume that's the same also in your case as well. But sometimes what happens is people say, I can't afford a similar environment like in production. So it will be more of a scaled down version of what you have in production, right? So as part of this proactive performance tuning only, all this indexes, we will try to use the PL SQL profiler and try to see where the code current, let's say in the test environment, it take 2 hours. You want to know where all these 2 hours is split up in a PL SQL code. Okay.
Yeah.
Sangamitra is commenting he hasn't seen a performance testing environment. Okay. Yeah. So having said that, right, these are the
So,
different scenarios where, sorry, were trying to say
yeah,
something?
so no, I'm saying just to Sangamitra, we have like we have testing environment, staging environment, production environment, something like that.
Okay. Yeah. And the other challenge with respect to performance tuning, right? It depends on the application that we work also. There are some critical applications where people expect responses in seconds or sub-seconds most of the time. I happen to work in a data warehousing environment where it's a typical data warehousing, like Manhattan Associates in Bangalore. They are into this big warehouses, like for people like Walmart, right? They used to scan the person in the warehouse used to scan the barcodes, and if there is any delay, right, in the scan, the response taking less than a second or 2 seconds, more than 2 seconds, his productivity comes down drastically. So it's to that extent, right? Sometimes there are some expectations in some shops where the responses needs to be maintained in seconds and sub-seconds. And how do we ensure it, right? So the second part is more in terms of uh, ensuring that the performance is in the way that we expect, right? So for all these things, like, right, so we talked about individual SQL tuning, batch program tuning, and sometimes system level tuning is required, where you see a system level performance degradation over a period of time. As the database load increases, you see a thing overall slowdown, and you might have to fine tune at the system level, at the SGA and the PGA level, right? But in general, right, the recommendations or the resistance from the team or from the most of the times DBS, right, we'll do it once or twice. We don't keep doing it on a daily basis, changing the SGS, PGS, right? And it's not
Yes.
recommended as well. So, right, people will first ask the application team, go and take a look at the SQL. Your only one SQL is not performing. Only when your query is running, database is right, going slow. Most of the other times, I have everything is running fine. You have a 64 GB databases also. It's there in the production. People have 64 GB databases with 32 core CPUs. Very big systems people have. And sometimes it just boils down to single query hogging everything, right? And sometimes in some systems you will see, right, the other thing is as part of proactive, you will see some rogue applications. Let's say a developer or a tester has run a wrong query, or a support person has run a wrong query in the database, and it's hogging up all the resources. You find out that one person has run a query, he's seeing it's taking a lot of time, he has just killed this session. He just closed his session and went, but the query was running in the background, right? Many times you would have seen it as well. So as during the entire course, right, we'll be covering all these scenarios, as I said, right? Individual SQL tuning, your PL SQL tuning, and tuning at the system levels, and proactively before in terms of deploying your new code into production, what are the things that you have to look into consideration? Right, so these are the different things that we will look in. And Oracle, right, as a product, database product, there was a tremendous in terms of functionality, the features that Oracle provide has grown like anything. The history is, right, Oracle has initially, when it started with running first maybe next 10 to 15 minutes I'll talk about SQL query tuning, and the next 15 minutes for at the system level we'll talk. So if you see, right, individual SQL query tuning, what happens, right, as part of the SQL query tuning is basically you come to know, right, you want to understand how the query works in the background, right? What we do, right, suddenly they come and say that this particular SQL is not working fine. So what are the things that you're going to do, right? So you guys want to give a
Yeah,
what's the normal?
normally like yeah, in that case, normally we find out which SQL is going to, like which SQL like taking long time, and we'll try to run the explain plan for that particular SQL statement. So that it's reading the full table scan or the index scan, something like I'll try to find out.
Okay, okay, great. So, and as part of this process, right, SQL query tuning, as you said, first thing we'll do is okay, let's say well, let's see the explain plan. We'll see the explain plan. No, Sangha, you are not audible. Am I not audible? No.
I think Sangha, I have to call from the phone. Maybe she can.
But phone, I don't know, Sangamitra. It's a US number it gives, or you can give your number and you will get a call. Yeah. How is it like?
We have the US number. They have provided the US number.
Okay. He says he will post his queries here. Okay. So normally what we do, the SQL query tuning is, right, the first step what we do is we'll try to see, we'll try to do an explain plan, and we'll see what is that, what is the cost associated with the explain plan. So the element of cost comes into the picture here, right? And we see the cost is very high. The people say the cost of your SQL query is very high. You have to tune it. Okay, and most of the time you will see some 3 or 4 tables in your select statement, and you see all these keywords like nested loops, hash joins, sort merge joins, right? So this is with respect to joining more than one table, right? I have to get data from more than one table. Most of the time, right, all your databases are normalized. And in a normalized database, and the information that we are looking is always from 3 or 4 tables. Minimum, you get to see 4 or 5 tables only in the SQL, right? Some complex applications. Minimum I'm talking about is 3 or 4 tables.
Yeah, minimum. Yeah. And they use a lot of merges.
Yeah.
Everything they add.
So that's the challenge, right? So in this session or in this class, what we will see is, right, if there are multiple tables in the from clause, right, how Oracle goes about, we'll try to understand, right, in this class we'll try to understand how Oracle goes about joining these tables. There are multiple tables. So what's the criteria Oracle uses to say it has to go for a nested loop join, or it has to go for a sort merge join or a hash join? And at the end of the class, right, you will be in a position to say why Oracle is using a nested loop join here. I think sort merge join will make things faster, right? Instead of nested loop, it should be using a sort merge join, because, right, Oracle as such, right, it's any software for that matter, you can say it's a garbage in, garbage out. You give the data, you create the required indexes, then Oracle tries to figure out what's the best based on the logic that's written, right, in the optimizer, to figure out what's the access path it should choose. Right, for us, for this class, some people would have, sometimes people take a class on their mobile itself. They see the screen in the mobile also. Some people do in their iPad, some people in their laptops, different ways to get this particular course material. Similarly, right, to get data from multiple tables, there are multiple ways. Oracle, the optimizer internally, right, it tries to figure out what is the best way for me to get the required output. So for me, the first step is at the table level. So Oracle has to decide at the table level whether it has to go for a full table scan, or it has to use an index scan. Okay, or it has to use the indexes. So on what basis Oracle decides whether it has to go for a full table scan or it has to use a specific index? So that's the next question, right? So what information Oracle has to decide whether it has to go for a full table scan or index scan? So Oracle needs to have some information, right? So that information is nothing but the statistics. The statistics we collect at the table. So when I collect statistics at the table, level, right, I get to know the number of rows in that particular table. Okay, and total number of rows, and for key columns, for the indexed columns, right, the number of distinct values, right? let's say the table has 100,000 rows and a primary key column or a unique key column, the number of distinct values will be unique. Let's say your unique number like passport and other things, right? It's unique. So the number of unique rows values will increase. Whereas other information like the place of living or city or a particular code kind of information won't be that unique. So Oracle captures all this information, and sometimes you will see, right, the data distribution also Oracle will try to figure out whether the data is skewed in the sense, right, a column can have only 5 values, but one particular value is there in 80% of the rows. Then we say that particular data column is skewed. The data in that column is skewed. So Oracle collects all this information, right, to figure out whether it has to you go for a full table scan or it has to use a specific index. So it's possible that, right, my particular column is there in 2 or 3 indexes. So which column Oracle has to use? Which index Oracle has to use? We all know the advantages of having an index, right? Index helps to quick retrieval of the data. So if you take a book without index, will we be in a position to identify a specific topic? No. Most of the time, right,
No.
any specific topics, we go back to the book, go and see the index, right? The same concept over here. So the next question is, right, how index access is faster? Why not the direct table access? People might ask. It stores everything in the database in the data at the table level, and it's physically stored in data blocks. Why index access is faster compared to I go and directly look at the table? So the answer comes out, right, more information about, by doing one physical read, Oracle can get information about multiple rows in one physical read compared to multiple physical reads. Agree, Anil? Right?
I didn't get you.
No, okay. So going back, right, so in this what we will cover, so now we are getting into the intricacies in terms of how Oracle stores the data, right? Physical storage. So we have something called physical physical storage and the logical storage. So what is the logical storage? Yeah. So what is a physical storage, right, with respect to Oracle database is nothing but data files, control files, control files, redo log files, right, log files. So all these are on the physical side. So what's on the logical side, right? So logical side, the high level
schemas, objects.
So logical side is table space. So one table space, right, that's where the physical and logical link is there at the table space level only. So when I create a table space, I associate it with a couple of physical files, or in case of ASM, it's not even files you do. You specify what's the thing and ASM takes care of everything, right? You don't have to worry about on the file side. ASM takes care. Yeah?
Yes, yes.
Yeah. So, right, but the files I created at 4 GB. So in one table space, right, you can have multiple tables stored against in one particular table space. And when we create it, and when we create a table, right, Oracle has to allocate some space for that table, right? Some storage space Oracle as part of the initial table creation, we used to do that. So this maybe in this class, I will try to, I'm just trying to give the flow. In subsequent classes, if you have any specific doubt on a specific topic that we are discussing, we'll dive into the details in the subsequent classes. Okay?
Sure, definitely. Yes, sir.
Okay. So when I create a table, right, what we do is, right, I say this table size 2 MB I can say. So how Oracle allocates the MB is more in terms of extents and blocks. Information in computer is stored in terms of zeros and ones, and zeros and ones are nothing but bits, your bits. And a higher level we have something called OS blocks, operating system blocks. Oracle allocates data in terms of data blocks. So when I create the database itself, right, I specify what is my database, DB block size I will specify. So that's the minimum granularity of physical space Oracle can allocate the database blocks. The next level is in terms of extents. Okay.
Yes.
On top of the extents, you have segments.
Segment.
Yeah. So any Oracle database object which has a physical storage associated with it, it will have a segment with it. Let's say a synonym, right? Now you know what is a synonym. So a synonym
Yeah.
doesn't have a segment associated with it. A view doesn't have a segment associated with it.
Yes.
Yeah, but a table will have a segment associated with it, and an index will
Segment.
have a segment associated with it.
Segment.
Yeah, right. So if you see here, right, maybe I'll just go to the, I'm just sharing few things on my screens, guys. Just wait. Okay. What do I do here?
We have cancelable. We cancel it right side.
That's what I'm seeing, but I am not able to. Okay, let me close this slideshow from beginning. I'll go to this particular. So this is what we discussed, right? Logical and physical storage.
Yes. Yes.
Yeah, you have OS block, nothing but I create a data file, one table space, multiple data files. In one table space, I can have multiple segments. One segment can have multiple extents, and
Multiple extents.
one extent will usually have multiple data blocks, Oracle data blocks.
Data block.
So when I create a table, I can say initially how many extents. Okay. But with respect to this physical storage and the logical storage, Oracle has tremendous advantage. Initially, right, people, you'll have a lot of interviews with respect to the physical storage related stuff, right? How things are getting stored, what will you use, what will be the PCT free, what will be the PCT used, right? If a table with less updates, how much you will give for PCT free, how much you will give for PCT used, what is a free list? Like now there is something called coalescing, right? Row chaining, all these concepts were there.
Yes.
But with locally managed table spaces, right? With locally managed table spaces, and there is something called ASSM, Automatic Segment Space Management. Oracle is saying you don't worry about how things are getting stored within a segment or within extents, within a table space. I will take care of it. I will store and retrieve it efficiently. You worry about your application code, right? So when I
Yes.
say, right, a table space is locally managed, more of the headaches with respect to row chaining, everything goes away. See, it's possible in one particular table, my application, right, I frequently insert data and I delete the data also. But some tables, we insert it once and we forget it. More of lookup or static data, I insert it once and I forget it, right? So, so for each table, different characteristics and different ways of doing things. Okay. I'll try to expand this. Yeah, Sangamitra. Yeah, exactly. Yeah, exactly. That's why we do table reorg, and we try out different things with respect to reorganization. And so if table which frequently gets inserted and updated, people what they say is put it in a different table space. There is a specific way of handling the PCT free and PCT used for tables where I insert some data in some columns and later point in time I insert data in other columns. The table, the row length keeps on increasing in some cases, or it might come down as well. So it's possible one particular table, for lot of rows, data exists in multiple data blocks, which leads to multiple physical IOs. So with respect to yeah, right. With respect to computers, right, it's mostly in terms of number of data blocks that we read and things like that. So this is what I was talking about. So if you see here, right, within the table space, right, you have multiple data files, and you can have multiple tables. Right, this is assuming these are two different data files. One table's data can exist in more than one data file as well, right? and indexes can be just exist in one physical data file or in multiple data files as well. So how Oracle knows, right? The next question is, right, more of internally in terms of when I issue a SQL query, what happens when we connect to a SQL session, right? So this is also the working that I want to say is, right, uh, uh, steps internally Oracle performs to retrieve a row or to save or retrieve a
Insert
row
or update.
and also for insert, update and delete.
Yeah.
Yeah, right. So let's say I issue a select statement, right? We say select star from table X where Y equal to this. So what Oracle does, the steps involved is Oracle uses the statistics and figure out
Yes.
figure out three or four different ways to retrieve that information, chooses the one which it assumes that it's going to cost less. So here when it is cost, it's nothing but the resources. So in terms of computer, right, what are the resources? CPU is my resource. How much memory I'm going to take, that's the resource. And the CPU, right, if I'm going to read more files, more data from my hard disk, then it's more work, right? So in terms of IOs.
Yes.
So these are the different factors, and Oracle determines, okay, I will retrieve the data from this table using this specific plan or using this specific approach. It retrieves the data and gives you that information. So when it does that, right, what are the different processes involved? If you see here, right, going back to this particular architectural screen, okay, previous, okay, down, 1 second. So if you see here, right, this is the architecture diagram. I will have a couple of classes, or I will split the time, right? I'm going to talk about this in some 3 or 4 classes, so that, right, it takes time for us to understand. Uh, since this is the main piece which helps us to understand how Oracle internally works, we'll be spending more classes in this, or at least initial few classes in this, to better understand, right? If someone asks you in Oracle does a SQL, right, you issue a select query, which process is responsible for reading the data from the physical file and showing it to you, right? Where that particular data is stored. So all this information we'll cover in the subsequent classes. And similarly, right, when you insert data into a particular table, right, it doesn't take, when you issue a commit, right, Oracle gives you the response in flash, whether you insert 1,000 rows or whether you insert 5,000 rows, or in one insert you insert multiple millions of rows or update millions of rows, the response time is the same for commit. It doesn't, there, hope you guys have observed, right? And
Yes.
yeah, so what are the processes involved in making sure my insert is faster, commit is faster, right? So we'll be covering all these topics as well in detail. Maybe in today's class, right, I will cover, I just have 10 more minutes. So high level, I will cover with respect to the select statement, right? So basically when we issue a select statement, what happens is, right, you have something called from your client. So that my client can be my SQL developer session or a toad session, or your application, right? Your Java, JDBC, from your JDBC connectivity, your web, from your Java code, you're calling the select statement. So that's the, that you don't see. That's the user process we are talking about. So first time when you issue a connect, right, when you try to connect to the database, there is something called listener comes into the picture. Listener is the process which is responsible to write the client request, initial client request goes to the listener validates, listener calls the other process, validates the username, password, everything, and then, right, once everything is fine, it creates on behalf of that particular user process a server process on the Oracle database server. So if you see in Unix, right, you do a ps-ef and you grep for the Ora keyword, you'll see a lot of processor running. So some are background processes and some are server processes. So any subsequent request, right, happens directly between your user process and server process. Any subsequent talk directly happens between your user process and server process. Yeah, Sangamitra, are you trying to say something? Hello?
He's in chat she typed something. Whenever database is up, we would also.
Yeah?
She asking some question.
Yeah, whenever database up, we also would be checking whether the listener is up. Yeah, exactly. Table reorg do we do for manually manage table spaces? Yes. Sometimes I've seen commit taking more time. Yeah, we will talk about that why it's taking more time. Right? Whenever database is up, we also would be checking whether the listener is up. Yeah. So listener is right. Listener, once a database session is connected, then that's it. You have thing. Listener comes into the picture when you're trying to establish a
First
new
time
connection,
connection.
first time connection. So if I'm already
Yes.
connected to the database and if the listener process is down, nothing matter. My connection still works. I'll be still able to query my database.
Yes.
Okay? That's right,
Yes.
right, Anil?
Yes, you are right. You are right, Ganesh.
Yeah. So that's
Please,
what
first time
happens.
connection listener is yes.
Yeah, listener is required. So now I issue a select statement. So what this server process will do, right, on behalf of the server process will go there. So server process has to figure out, right, this particular table data is stored where. So it will go to this, there is something called shared pool. So
Shared
shared
pool.
pool, and you have something called data dictionary cache. Okay, so you have heard of tables like DBA segments, DBA extents. So DBA extents has information about which tables data is in which particular data file and in which particular block. Say in a 4 MB, 4 GB file, the exact location of this particular table's data, that information is available in your data dictionary cache. The server process will go and read over here. You will see whether that particular information is available in the memory already. If it's not available in the memory, it has to go to this physical file and fetch that information and put it into the data dictionary cache. So when you start the database, some information Oracle preloads into your shared pool, everything, right? Data dictionary cache. So now the server process knows where the physical file it has to go. So it will go to this database, fetch all the blocks that are relevant for your table, right? Comes into here. You have something called database DB block buffer cache, database buffer cache. So all the blocks, we said the data is stored in terms of database blocks. So all the blocks for your query will be fetched into your database buffer cache, right? So now it has only
Okay.
that particular table data is there. Then Oracle, what it has to do, your server process will go through, will see whether the database blocks can be from an index or from the table itself directly. Then it starts applying the predicates, filters out, put your data into your session. If any sorting is required for your data, it does the sorting over here. In the PGA, it does. Your data comes into your PGA. The data for your query, it sorts the data, and then the server process returns that information. In this diagram, right, there is no link between your server process and PGA. So not to make things complicated, they have done this in this
Okay.
specific way, right? But usually, right, for every for every server process, right, every user process, there is something called it will have its own memory. Okay, and there is some memory which is commonly available for all the connections, database connections, right? And also we have lot of processes. So in subsequent classes we will cover what happens right, someone has killed my session. So who will free up, which process is responsible for freeing up my killed session information? The server process, whatever is being killed. Or I issued an update before commit, my session got killed. So how the data will be cleared? Similarly, right, your database has crashed and you're bringing up your database back. So which process is responsible for recovering your instance? Which process is responsible for writing your, the DB writer process is responsible for writing all your insert and updated information back to the data files. how Oracle ensures when you issue a commit, right, irrespective of whether actual physical write is written or not, how Oracle ensures that when you, the durability is maintained. We talk about database ACID properties, right? There is something called durability. Once you issue a commit, Oracle says 99.999% I will get you back that data. And it gives you back that data. We never heard people saying, oh, after commit database crashed, I lost my data. It never happens. So how Oracle internally does all these things, right? So we'll cover this in this class. So as I said initially, right, we will, I think we are running out of time as well. So I don't know. Uh, so in the subsequent classes, we'll be covering all these topics, and we'll be spending more time in terms of architecture and the indexes as well, right? Why we create indexes, how index access makes things faster, what are the different types of joins, nested loop join,
Yeah.
hash join, sort mode join, what is
Yeah.
that, what we should do, even hints, right? Sometimes you guys would have seen hints as well, right? So hints we'll cover, hints stored
Yes.
outlines.
And parallel.
Hence, stored outlines. Stored outlines is outdated now. Now it's SQL plan management, right? And partitioning, table partitioning, how partitioning helps parallel running a query, parallel queries, right? So we'll be covering all these topics in subsequent classes. And also, right, whatever the topics that's mentioned or shared with you people, right, in the GangBoard, we'll be covering those topics as well. If you want me to send a formal course content also, I will send it after this class. Okay?
Yeah, we have Ganesh. I have. And how how can we know like how is our next classes timings and all the stuff? So we need to check with the from Ganban.
Yeah. So Sangamitra, you have to come online. You have to try speaking now. So I suggested the morning time, 7 a.m. to 9 a.m. IST my time, right? So that's convenient for me. So I'm not sure about
Yeah,
you
for me
people.
as well. For me as well because I'm in the California. So evening time we can after office we can work. We can sit here.
Okay. Oh, so
I'm very comfortable.
Sangamitra, what about you? You can get, see again,
She
right?
also
It's a
convenient.
demo.
She also
Sorry?
convenient. Convenient.
Oh, if I dial through the phone, is that toll free?
So we have the number here. We can we can dial the number.
Oh, we can dial
We
the
have the
number.
US number. We can from US we can dial the number. We have the US number.
Okay. Yeah. So Sangamitra, with respect to your connections, right, we can figure it out. I have taken classes for students in Pune as well. So we can figure it out. So once you guys confirm, right, we can start the class from next Monday. That is what I'm trying to say is where we are. We can start from 20th. Is that fine?
Once again, Ganesh is 28th is Monday. Yes,
Yeah.
comfortable.
Yeah, so I leave it to you. Maybe if you want to think through and then confirm also, please confirm it with the institute. I will also speak with them and then we can move forward.
Yeah, please inform them like is like, comfortable for them as the video recording all the stuff.
Yeah, yeah. So I can
So
do,
it's not
yeah, I will do that. I will confirm with them because what they have given me, the GoToMeeting account is a demo account. So I will check with them and then
sure.
we can
So
proceed further.
so we have the
So
today's yeah,
yeah.
we have the today's demo recording that we can test it something like that so we can confirm like,
Yeah,
further
yeah.
on that.
Take your time to confirm. What I'm saying is, if you're going to start the class, we'll start from next week. And I prefer to write. I prefer to have breaks in between so that you can take some time to digest. Right, a day or two break in between. You will have. Not on a daily basis. We'll have classes that way, right?
Okay.
If you have 3 or 4 days continuously, then one day I want you to spend that 2 hours going through the material what we have gone through. So only then, right? Only then it will add more value. So
Exactly, Ganesh.
okay. 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 Any other queries from you guys? Sangamitra, I will call you now.
Oh, Sangamitra is from India.
Yeah. Can I have your number 988?
So we can start from next week, Ganesh. I'm very much comfortable from your class, so we can start from next week.
We can start from next week, right? Okay. So
Yeah, I'm very comfortable.
maybe after this, once I stop this recording, right, I will just give a call to Sangamitra and I'll try to figure out how best we can sort out this audio issues, right? So
Sure.
maybe before next class, we'll make sure that Sangha is also comfortable with respect to right audio issues is sorted out so that we can get started.
Yeah, sure, exactly. Yes, we can.
Yeah, we'll do that. Okay.
Sure. And thanks a lot, Ganesh, for your help for this.
Yeah.
Training.
No issues. Yeah, it's my pleasure. Yeah, I've been doing it for some time, so I'm really enjoying it. So, okay, nice
So this
talking
is
with you
my
guys.
sure. Yeah, we are you to see. Thank you.
Yeah, thank you. Thanks.
Thank you, Ganesh. Yeah.
Yeah, thank you.